Okay, so problem. Find the moment of inertia about the centroidal x-axis and y-y axis of the angle section as shown in figure. So this angle section, it is divided into two rectangle parts. Okay, so this one, it is first rectangle parts. Here, this one is first rectangle parts. This is first rectangle part. This one, it is second rectangle. Okay, second rectangle part. So now, first of all, calculate the y bar. Y bar is equal to y bar is equal to y bar is equal to formula for that a1 y1 plus a2 y2 y2 divided by a1 plus a2 divided by a1 plus a2 plus a2. Okay, first of all, a1 it is calculated first part, first rectangle part. So its height, it is total 100 into so width, it is 20 20. So 100 into 20, it will be get 100 into 20, it will be 2000 mm square. So area, it is 2000 mm square. So this one, it is a1. Okay, so now calculate y1 is equal to, so first of all, draw the x-axis and y. Okay, so this one, it is y-axis. This is y-axis, and then x-axis. This one, it is x-axis. So y1, it is measured from the x-axis. It is center of this depth, means total height, it is total depth, it is 100 by 2. So this distance, it is 100 divided by 2. 100 divided by 2. Okay, y1. So just calculate y1, it is 100 divided by 2. Okay, so y1, it is measured from the x-axis. Okay, so part 1, it is first rectangle part. Total height, total depth, it is 100 mm. So it is measured from x-axis. Half of this depth means 100 by 2. So it will be 50 mm. 50 mm. 100 by 2, it is 50 mm. Then second one, it is a2. a2 is equal to so this distance we must be known. So this is second rectangle part width. Okay, so how much this one, it is total, it is 80 minus this 20. So this one, it is 80 minus 20. Okay, so this distance, it is 80 minus 20. So total distance, it is 80, and this distance, it is 20. Okay, so this distance, it is 20, and this distance, it is total 80. 80 minus 20, it will be at this distance. Okay, so is equal to 80 minus 20, it is 60 into height, it is 20 is equal to, so 60 into 20, it will be get a2 value. 60 into 20, it will be 1200 mm square. 1200 mm square. Okay. This one, it is a2. So now calculate y2. y2 is equal to y2 is second part, it is this distance. So it is measured from the x-axis. Y2, it is measured from the x-axis. So half of this 20 divided by 2. It will be 20 divided by 2. 20 divided by 2. 20 divided by 2, it will be get 10 mm is equal to this 10 mm. Okay. So put all this value in y bar equation. y bar is equal to, here a1 it is how much? A1 it is 2000, then y1 it is 50 mm, then plus a2 it is again 1200 mm, 1200 mm square, and y2 it is 10 mm, 10 divided by divided by divided by a1 plus a2. So a1 it is again 2000 plus a2 it is 1200, 1200. So y bar, it will get y bar from this relation. So y bar is equal to, calculate 2000 into 50 plus 1200 into 10 divided by 2000 plus 1200. It will get 35 mm. Y bar is equal to, it is 35 mm. Okay. So I will note down y bar value, it is 35 mm. Okay. So now calculate moment of inertia. Calculate moment of inertia. First of all, about the x-axis, then y-axis. Now calculate moment of inertia. Moment of inertia about x-axis. X-axis. Okay. Moment of inertia. Of inertia about x-axis. Okay. X-axis. So I-axis is equal to x-axis is equal to ix1 ix1 plus ix2 ix2. So ix1 like parallel axis theorem for ix1 and ix2. So first of all, ix1 is equal to ig1 plus ah square plus a1 h1 square plus a1 h1 square. So ig1 it is first part. So it is ig1 it is bd cube by 12. Okay. So formula it is bd cube by 12. B it is here 20 mm and D it is 100 mm. B it is 20 and D it is 100. BD cube divided by BD cube divided by BD cube divided by 12. So B it is 20 and D it is 100 mm. BD cube divided by 12. 12 plus A1 it is 100 into 20, that is 2000 mm square. 2000 mm square into h1 square. So h1 I will write here. h1 is equal to this y bar minus h1 it is y bar minus y1 y bar minus y1. Okay, y bar minus y1. So y bar it is how much? Y bar it is 35. Y bar it is 35 minus y1 it is 50. 100 by 2 it is 50 y. Okay, 35 minus 50, it will be minus 15 m. Minus 15 m. So h1 square it will be minus value, minus 15 square. Okay. If we done square, then it will get minus value, it will get plus value. Okay. So it will get ix1 from this relation. So write down ix1 is equal to calculate 20 into 100 cap 3 divided by 12 plus 2000 into 15 square. 15 square minus 15 square, it will get plus 15. So it will be 2. So answer it is 2.116. 2.116 into 10 raised to the power 6 10 raised to the power 6 mm raised to 4 mm raised to 4. So this one it is Ixx1. Okay. So now calculate Ixx2. Ixx2. Ixx2 is equal to, it is Ig2 plus Ig2 plus A2 H2 square. Ig2 plus A2 H2 square. Okay. So Ig2 again here Ig2 is equal to, it is BD cube by 12. So B it is for second rectangle part. So B it is this one it is total 60 mm. Okay. So B D cube by 12. So B it is 60. B it is here for second part, second rectangle part. B it is 60 and D it is 20. 60 into 20 cube. 60 into 20 cube divided by 12 divided by 12 plus A2 it is 60 into 20, that is 1200 mm square. 1200 into now H2 is equal to, write down H2 is equal to this y bar minus H2 I will write here y bar minus y2 y bar minus y2. So y bar it is how much? Y bar it is 35 and y2 it is 10 mm. This one it is 25 mm square. Sorry, 25 mm. So write down here 25 square. Okay. H square, that is 25 square. Okay. So now from this relation it will get Ixx2 value. Ixx2 is equal to 60 into 20 cap 3 divided by 12 plus 1200 into 25 square. So it will get Ixx2 will be 790 into 10 raised to the power 3 mm raised to 4 mm raised to 4 mm raised to 4. So this is Ixx2. Okay, Ixx2. Now calculate Ixx is equal to, Ixx is equal to total moment of inertia is equal to Ixx1 plus Ixx2. Okay. So Ixx1 it will be how much? Ixx1 is 2.116 into 10 raised to the power 6. 10 raised to the power 6 plus Ixx2 it is 790 into 10 raised to the power 3. 10 raised to the power 3. So from this relation, total moment of inertia will get Ixx is equal to, so 2.119 into 10 raised to the power 6 plus 790 into 10 raised to the power 3. So it will get 2.906. 2.906 into 10 raised to the power 6 mm raised to 4. So this is total moment of inertia. Mm raised to 4. This is total moment of inertia. Ixx is equal to. Okay. This is total moment of inertia. Okay. So now calculate x bar. Okay. So now calculate x bar. Write down x bar is equal to x bar is equal to x bar is equal to. So you can write down our moment of inertia about moment of inertia about about y axis, about y axis, about y axis. Okay. So first of all, for that we need to calculate x bar. X bar is equal to x bar is equal to x bar is equal to a1 x1 a1 x1 a1 x1 plus a2 x2 a2 x2 divided by a1 plus a2 divided by a1 plus a2 a2. Okay. So for that, calculate x1 value. X1 is equal to, so a1 it is same, a1 it is 100 into 20, that is 100 into 20, it is 2000 mm square. We are already this calculated 2000 mm square. Then x1 it is, now we need to calculate x1. So x1 is equal to so this one it is measured from the y axis, measured from the y x1 it is measured from the y axis. So for first part it is half of this part. Okay, first part it is this one, this distance, half of this. Okay, total it is width it is 20. Okay, it is measured from the y axis, 20 divided by 2. So x1 it is 20 divided by 2, 20 divided by 2, 20 divided by 2 is equal to 10 mm, 10 mm. Then a2 it is again, a2 is equal to, a2 is equal to, it is 60 into 20, that is 1200 mm. So we are calculate this one, it is also write down directly 1200 mm square, 1200 mm square. Okay, so now calculate x2 value. X2 is equal to, write down x2 is equal to, so first of all this one it is located at what distance from the y-axis? It is located this distance. So how much this distance? It is 20 plus 20 plus 20 plus 20 plus. Now total this one it is 60 mm, 60 by 2. Okay, half of this 60 by 2, 60 60 divided by 60 divided by 2, 60 divided by 2, 20 plus 60 by divided by 2, 60 divided by 2. So it will be how much? 20 plus 60 by 2, it is 30, 50 mm. So total it is 50 mm. So right one is equal to a1 it is again 2000 mm square, x1 it is 10 mm plus a2 it is 1200 mm, then x2 it is 50 divided by a1 plus a2 divided by a1 plus a2. A1 it is 2000 plus 1200 mm square. So from this relation it will get x bar. Okay. X bar is equal to random. X bar is equal to, we get x bar from this relation. X bar is equal to x bar is equal to x bar is equal to, just calculate this one, it is 2000 into 10 plus 1200 into 50 divided by 2000 plus 1200. So x bar it will be get 25 mm. X bar is equal to this 25 mm. Okay. This is your x bar value. Okay. So now calculate moment of inertia. Iyy is equal to Iyy1 plus Iyy2. Iyy2. Parallel axis theorem. Here it is also we need to apply parallel axis theorem. Parallel axis theorem. parallel axis 0. First of all, calculate Iy1. So we'll write Iyy1 is equal to Iyy1 is equal to Ig1 plus Ig1 plus A1 H1 square. A1 H1 square. Okay. A1 H1 square. So Iyy1 it is equal to Ig1 it is, for first it is here dB cube by 12. Here Iyy it is dB cube by 12. So D it is what is here? D it is 100. D it is 100. B it is 20. dB cube by 12. Okay. That's why dB cube by 12. Okay. So this one it is D and this one it is B. Okay. So dB cube by 12 divided by dB cube divided by 12 plus A1 it is again 2000. Now H1 here. See here H1 is equal to, it is here x bar minus x1 x bar minus x1 okay, x bar minus x. So x bar it is how much? X bar it is 25 mm and x1 it is 20 by 2, that is 10 mm. So this one it is 15 mm. Okay, 25 minus 10, so it will be 15 square. Okay. So now Iy1 it will be get from this relation. Iy1 is equal to, calculate 100 into 20 cube divided by 12 plus 2000 into 15 square. So it will get 516 516.67 into 10 raised to the power 3 mm raised to 4. So this one it is Iy1. Iy1. So now calculate Iyy2 is equal to Ig2 plus A2 H2 square. Okay. A2 H2 square. So same Iyy2 is equal to, so Ig2 it is BD cube by 12. So B it is here, sorry, DB cube by 12. So here Iyy2 it is Ig2 value it is DB cube by 12. So D it is here 20 DB cube 60. D it is 20, B it is 60. So DB cube divided by 12 plus A2 it is 60 into 20, that is 1200 mm. Then H2 value now. H2 is equal to, I will write here, H2 is equal to x bar minus x2. X bar minus x2. So x bar it is 25 minus x2 it is 20 plus 60 by 2, that is 50 mm. So it will be get minus 25 mm. So here minus, it will be get plus value. Okay. So minus 25 square. So it will be get Iyy2 from this relation. Okay. So Iyy2 is equal to, write down Iyy2 is equal to, so 20 into 60 cube divided by 12 plus 1200 into 25 square minus 25 square, it will be get plus 12. It will be get 1.11 into 10 raised to the power 6. 1.11 into 10 raised to the power 6 mm raised to 4. Mm raised to 4. So this is IYY2. IYY12. Okay. IYY12. So IYY is equal to, right, IYY is equal to, it will be IYY1 plus IYY2. IYY2. So IYY1, it will be how much? IYY1, it is 516.67 into 10 raised to the power 3 plus IYY2, it is 1.11 into 10 raised to the power 6. Okay. So total IYY it will be get from this relation. IYY is equal to, write down, total moment of inertia about IYY, it is 516.67 into 10 raised to the power 3 plus 1.11 into 10 raised to the power 6. So it will be 1.626 into 10 raised to the power 6 10 raised to the power 6 mm raised to 4 mm raised to 4. So this is I1. Okay. So moment of inertia about I-axis and IY. So question was, find the moment of inertia about centroidal axis and YY axis. So I-axis were calculated. This one it is 2.907 into 10 raised to the power 6, and IYY it is 1.626 into 10 raised to the power 6 mm raised to 4. Okay, this is your final answer.